Now, we've seen some examples of how bindings of variables take place when functions are called. Let's do a couple of other examples to just really reinforce this point, because it's really important for you to understand bindings of variables and how they take place. So for this one, I'm actually going to just go over to Python and idle and type in a little example. Imagine I say I'm going to create f of x to have the following property. I'm going to bind y to 1. I'm going to bind x to be x plus y. Oops, sorry. I'm going to then print out the current value of x, that x is equal to I'm printing out the string x is equal to and then the actual value of x. And then I'm going to return the value of x. And now, inside of Python, I set x to 3. I set y to 2. I'm sorry, I mistyped that, so let's do that properly. There's y is equal to 2. And I bind z to be f of x. Okay? And I run it, and it says x is equal to 4. And if I now ask what's the value of z, it's 4, x is 3, and y is 2. Okay, I want to see, so why does that happen? Why is it that x is now returning an internal value of 4 here, but externally is 3, and z is 4, and y is equal to 2? Why does this happen? This is going to give us a chance again to look at what happens inside of the binding. So let's look in detail at what happens here. I create a definition of f, and in my global environment for Python, that says I've got a binding of f to that procedure. And I remind you, inside there's the formal parameter for x, and there is the interior. I didn't repeat all of it, it's got that print statement to it, but basically there is that interior that deals with all of those pieces. And notice that it's just there as text. It hasn't actually been evaluated yet. I then go ahead and do the bindings of x is 3 and y is equal to 2, and at this stage in the computation I've got bindings for them inside the environment. Key thing to notice, in the global environment x is 3, y is 2, and f is bound to a procedure object whose body has references to x and y, but nothing more. Okay, let's move on in the computation. I now say I want to invoke f. I'm going to eventually bind z to the value returned by calling f on x, but I'm invoking f of x right there. What does that do? Well, I get the binding for f, which is this procedure, and that says I'm going to copy this environment pointer, so I'm going to create a new frame whose parent is that global environment, and inside there I'm going to bind a parameter x, that is coming from there, to the value passed in by the value of the call to f, and that x refers to this one. Okay, a little funky, but it's important to see that the rules actually tell me how to do that. My invocation of f says create a frame in which the formal parameter x is going to have a binding. And what's the binding for that value? It's the value of this expression, and that expression is a variable name, so I'm doing that evaluation here in the global environment. I get that value of x, which is 3. Okay, so I've now created a local binding for x to be 3. And now I'm ready to move on. So relative to this environment, I'm now going to evaluate the body of f. So let's step on. The body of f says, first expression is to create a binding for y. And remember, that's happening here. That's happening in the frame associated with the function invocation. So I'm going to bind y to have the value 1 there. That's interesting because it's not changing things up here. It is making that binding there. So that step of the computation creates that change. And if I now move on, the next expression in f says get the value of x. Remember, I'm doing that relative to this frame. Get the value of y, which I'm doing relative to this frame, and then do that computation and change the binding, which is why it goes from 3 plus 1, and I'm changing that binding to 4. From the perspective of f, it never sees that version of y. It only sees this version of y. From the perspective of x, it only saw that version of x, which was originally 3. And then the binding, this happens in this frame. And that's why that version of x changes. Having done that, we can move on, and it says, oh, return the value of x, which is 4, and that is what z is going to be bound to. And that binding, remember, takes place up in this frame because that expression is being evaluated relative to the global environment. It's a long-winded way of saying, notice that this particular expression here, the body of f, got a value for y that it had bound locally, got a value for x, which was the local parameter, and did the change locally inside of that environment. But the return value was a binding that took place up in the global environment. And that's why if I were now to go ahead and print out, control reverts to the global environment, and that's where the values of x, y, and z are visible, which is why I am going to, in fact, now do the values that I saw printed when I did that in my environment. So the point of this is that those bindings actually take place in frames that make sense. So here are some observations. Each function call creates a new environment, a new scope, where the bindings of the formal parameters and the values passed in take place. And where, as we saw, local variables, things created as assignments within the body take place, that local binding of y. And that creates an environment in which we actually do the computation. This scoping is often called either static or lexical, because the scope within which a variable has a value is defined by the extent of the code boundaries. That definition of f had lexically a scope around it that said, I'm locally binding y, I'm locally using the formal parameter x, all computations take place within that scope. And so that gives us a sense of why we see the particular examples that we just did.